thin lens formula or lens maker's formula. Means here already we have discussed about that different type of lenses, that is convex called converging lens and concave diverging lens. By using that lens, the formation of the image also we have discussed, that the types of lenses and where the object is placed, then the what is the image formation from the convex or concave lenses, already we studied about that. Now we are going to discuss about that lens maker's formula, the what basis of different focal lengths of lens are made. By using this formula we are going to discuss. Now to know this, I am going to take the two equiconvex lenses of radius, equal radius R1 R2, means R1 R2 be the R1 R2 be the radii of lenses. Radii of lens means if we write that the center of this, the center of the primary one and the center of the secondary one, we are taking that the two equiconvex surfaces, that is the first surface and this one is the second surface, and which is having the, it's a coaxial, means it is having this is the optical center. When an object is placed at point O at a distance of u from the optical center, means u be the distance object is placed when the light is incident on the first surface of the lens. First surface of the lens. If we don't consider the second lens, then we can say that here this is the second surface, this is the first surface. So here it is that when the light is incident on the first surface, if we don't consider, if there is no any second surface, means second lens, the light image, the image of this light will incident on this point I dash, means it's a virtual image. Virtual image is formed if there is no any second lens. If there is no second lens, then here the image is maybe formed at I dash at a distance of the optical object is optical image is optical center is V dash. Means here the distance is say thin lens, so that's why we can take the distances from this also, all the this one the pole also. So at a distance of V dash, the virtual image can be formed if there is no any, another lens. Then the refractive index of the ear is also medium is air, which is having the refractive index is mu1, and here is also air, this is also taking as mu1, and the lens is there, that is mu2. Refractive index of the lenses is mu2, we are taking that. Here actually if there is no any second lens, the light may be instant image can be formed at the I dash, because of when the light ray is passing from the rarer medium to the denser medium. Here air is the rarer medium and lens be the denser medium. So that's why when the light is traveling from rarer medium to the denser medium, light bends towards the normal, means this is the normal, here is the normal. When the light is incident on that, it is moving towards the normal. So here is that the image can be formed at this point. If in case the here, then here we are taking the normal, means here we are taking the normal, then we can get the value. This is the normal thing, means if we write this total the first surface, then this will be the center, then center means this is the C1, means here is the normal, we are writing that, then it is the light ray is moving towards the normal, so that's why I1 is the image is formed. If for the second lens, here is the center C2, means it is having the radius of R2 radius, then here we are from the refraction, from the formula of refraction, from the refraction at spherical surfaces, we have the formula for that, that is mu2 by V minus mu1 by U, that is equal to mu2 minus mu1 by R. Here just listen carefully, mu2 be the refractive index of the material where the light is going, The mu2 be the refractive index of the material which is the light is going, and mu1 be the refractive index of the material from where the light is coming. Where the light is coming. So mu2 is the where the light is going, mu1 be the where from the light is coming from that medium. Then here V be the distance of the image formed, and U be the distance of the object is placed. All the distances must be measured from the optical center. So by using this formula, from the if we come for the first surface, if we come for the first surface, means light ray is passing from rarer medium to the denser medium. Denser medium means here rarer medium refractive index is mu1 and a refractive index of lens is mu2. Here the distance of object is equal to u, and distance of image is equal to v. We are not mentioning any sign convention. We will give the sign, we will apply the sign convention later. Now we are doing the calculation. If we did now, then we get confused by the calculation. So that's why we did later. We apply the sign convention later. So whenever we apply this one, mu2 be the where the light is going, means the light is going into the lenses. So that's why here mu2 means the image is formed, means this is the not actual image, this is a virtual image. It may be, if there is no any second lens, then the first lens can be make the image at point I dash, means that's a virtual image, it's a fake image. So that's why here mu2 be the where the light is going, means the lens, the light is moving into the lens. So that's why mu2 by V, mu2 by V dash. V dash means the virtual image formed at a distance of V dash, minus here the image means the where the light is coming, the refractive index of the light is coming from the air. So that's why here mu1 be the refractive index of the air by the distance of object placed from optical center is distance is u. So that's why here we are writing that u. Next mu2 minus mu1 by the radius of lens is r1, means here is the r1, first r1. Then consider it's a question number 1. Then if we come for the second surface, means here when the light is formed a virtual image at point I dash at a distance of V dash, then when the second spherical mirror is placed, then here the light is moving from the denser medium to the rarer medium. When the spherical secondary surface taken, then the light is, whenever the light is coming from the rarer medium to the first surface denser medium, again after that whenever second surface is connected, then light is moving from the denser medium to the rarer medium. When the light is moving from the denser medium to the rarer medium, the light moving away from the normal. So here is the normal, consider center, then this will be the normal, then light is moving away from the normal. Then image is formed at actual image, real image at a distance of V. The real image is formed at a distance of V. So here it is that here the I dash can be acts as a virtual object. Here we can write that I dash acts as a virtual object for second surface. So that's why here we can write that this is the object for the second surface. The I dash is the virtual image, can be acts as the virtual object for the second surface. So here it is writing that here the distance, this will be the where the light is going. What is the light, where the light is going? mu2 means here this is moving from the rarer medium to the denser medium in first case. In second case, light is moving from mu2 to mu1, means it is moving from the lens to denser medium to the rarer medium. So here it is that first of all we are writing that mu1 by at a distance, this will be the distance of an object. This will be the distance of an object, means it is moving from the denser medium to the rarer medium. At a distance of v, the image is formed. So here it is that is v, and here light is coming from this point, means from the denser medium to light is coming from the denser medium. So that's why the denser medium refractive index is mu2 by, at a distance of, this will be the behaves like a object for the second surface at a distance of v dash. So that's why mu2 by v dash is equal to, here that is a mu1 minus mu2 by r2, mu1 minus mu2 by r2. Here is that second equation. By adding two equations, adding equation 1 and equation 2, then we can get mu2 by v dash minus mu1 by u plus mu1 by v minus mu2 by v dash is equal to, here mu2 minus mu1 by r1 plus here mu1 minus mu2 by r2. Then we can get that from this, we are taking here mu2 by v dash and mu2 by v dash get cancelled because of plus symbol and minus symbol. Then from this relation we take in common as mu1 we can get 1 by v minus 1 by u, that is equal to, here I am taking common as mu2 minus mu1, then we can get that here 1 by r1 minus 1 by r2, because of here mu2 minus mu1 be the mu2 minus mu1. Here whenever we take in comma minus multiplied with minus, then we can get this equation, means mu2 minus mu1 minus into mu2 minus mu1 minus into mu2 minus mu2 minus into minus plus mu1 by r2 we can get. So here it is that mu2 minus mu1 into 1 by r1 minus 1 by r2. Then mu1 taken to this side, it will becomes denominator, that will 1 by v minus 1 by u is equal to mu2 minus mu1 by mu1 of 1 by r1 minus 1 by r2. This can be considered as a equation, means lens maker's formula. This will be the lens maker's formula. And for that equation also we can write that, so 1 by v minus 1 by u is equal to, whenever we continue that's one mu2 by mu1 minus 1 into 1 by r1 minus 1 by r2. This is called as a lens maker's formula. Lens maker's formula. When the light is, object is or light is coming from the infinite distances, means the object is placed u is equal to infinity, then the image is formed at the focus, means let's take this, when the light is coming from the infinite distances, then it will form image formed at a focus, means here whenever u is equal to infinity, then v is equal to f. When the light is from the infinity distances, image is formed at a focus, v is equal to f. So here it is that when we substitute that one, then 1 by f minus 1 by infinity is equal to mu2 by mu1 minus 1 into 1 by r1 minus 1 by r2. Then we can get 1 by f is equal to mu2 by mu1 minus 1 into 1 by r1 minus 1 by r2. Actual lens maker formula, this is the actual lens maker's formula. This is lens maker's formula. Lens maker's formula. Consider here, consider this the equation number 3, or we can consider this also. This is considered equation number 3, and this one is 4. Comparing equation 3 and 4, equation 3 and 4, comparing equation 3 and 4, then we can get a 1 by f is equal to 1 by v minus 1 by u. This is called a thin lens formula. Thin lens formula or a lens formula. Thin lens formula or a lens formula. Means once again, when the image is a object is placed at infinity, light moving from the infinite distances, then image is formed at u is equal to infinity. The image is formed at the focus. So that's why v is equal to f. V is equal to f means here the image is formed at the focus. So that's why if we substitute these values in the equation, then we can get 1 by f minus 1 by infinity, that is equal to mu 2 by mu 1 minus 1 into 1 by r1 minus 1 by r2. Then from that equation 1 by f is equal to mu 2 by mu 1 minus 1 of 1 by r1 minus 1 by r2. Then this is the lens maker's formula. By comparing this equation 3rd and 4th, then we can get that 1 by f is equal to 1 by v minus 1 by u, that is the thin lens formula or a lens formula. This is about a lens maker's formula. When the light is passing from O to object is placed at O at a distance of u, the light is incident on the first surface of the lens. Then if there is no any second lens, then the light can be form the image at a I dash at a distance of v dash. So here is that due to the refraction due to the first surface, then we have the formula for refraction on spherical surface is mu 2 by v minus mu 1 by u, that is equal to mu 2 minus mu 1 by r. Here we can write that mu 1 where light is coming from, light is coming from, and mu 2 be the where light is going, where light is going. And here is also we are taking that mu 1 means when the light is coming from the, here is that, so that's the mu 1 be the air is the where the light is coming from the object, here is incident on that and formed the image, virtual image at I dash. Then if the second surface can be taken due to the refraction at the first surface, then mu 2 by v dash. Mu 2 means the first equation, mu 2 means where the light is going into the lens, so that's why mu 2 be the refractive index. The image is formed at the distance of v dash, virtual image, that means a fake image, there is no any image. If we consider we don't consider the second lens, then the first lens can be formed the image at I dash at a distance of v dash. So here is that mu 2 be the distance, mu 2 be the refractive index where the light is going. So that's why here mu 2 be the light is going into the lens, so that's why mu 2 by the image can be formed at v dash, so that's why v dash we are taking minus mu 1. Mu 1 means where the light is coming from, at air means the refractive index of mu 1, so that's why we are taking that mu 1, that the object is placed at the distance of u, so that's why u is equal to mu 2 minus mu 1 by at the radius of a lens, means the first lens, means this is the first surface. If we take this, then this is the radius of a lens, that is r1, and this is r1, and that will be the r2, that is called r1 taken the first equation. Then further if we come for the second lens can be taken, then here light is coming from the denser medium to the rarer medium, means the light is coming from the denser medium and moving into the rarer medium. Here the mu 1 is the where light is coming from, but in case of second thing, the light is coming from the denser medium, so that's why we are taking that moving from the denser medium and moving into the rarer medium. First where the light is going into the air, means here the image is formed. If we consider the second spherical mirror lens, then here the image is formed at a real image formed at a distance of v at point of I am the principal axis of the side. So then we can get that mu 1 by v image is formed at a distance of v, light is going into the rarer medium, so that's why here mu 1. This is for this formula, this equation, the given that the explanation for this formula only. If we consider that this is the where the light is going, this is where the light is coming from, so here it is that also light is going into the second medium, means second medium refractive index is air, so that's why air mu1 by the distance of the image is v, minus where the light is coming from the denser medium, that is refractive index of mu2 by the image, the I dash can be acts as a virtual object for the second surface, so that's why here that is the image is formed at a v dash, so that's why this is the object is placed at a distance of v dash can be taken by mu1 minus mu2 by r2. Then from the relation, if we added both one by the calculation of, we can get 1 by v minus 1 by u is equal to mu2 minus mu1 by mu1 into 1 by r1 minus 1 by r2. From this is called a lens maker's formula. If in case of, if the image is formed at a v, so that's why we can get 1 by v minus 1 by u is equal to mu2 minus mu1 by mu1 into 1 by r1 minus 1 by r2. Then from the relation, this is lens maker's formula. If the light is coming from the infinity distances or object is placed in the infinity distances, then u is equal to infinity, then v is equal to the image is formed at the focus. If in case of a convex lens or concave lens, whatever the biconvex lens or concave lens. If in case of concave lens we taken, then if the light is incident from the infinite distances, then this is the principal axis, the light say diverging, it's a diverging. So from the diverging also we can take that the image is formed at the focus only. The image is formed at the focus only. So that's why here we are taking that u is equal to infinity and v is equal to f. Then here by taking the values, then we can compare that 1 by f is equal to mu2 by mu1 minus 1 into 1 by r1 minus 1 by r2 be the lens maker's formula. And if we compare this equation and third equation, then we can get that the 1 by f is equal to 1 by v minus 1 by u, that is called as a thin lens formula or a lens formula. So